Anil and I am a student at Dr. Ambedkar Institute of Technology, Nagarpai, Bangalore. Today I am presenting my project titled Hearing Aid Using Digital Signal Processing as part of the Altair Embed Contest 2025. I have used two Altair products in this project. One is Altair Compose and one is Altair Embedded. So Altair Compose for digital signal processing and audio generation, and Altair Embed for real-time spectral analysis and output visualization. The object of this project was to design a simple digital hearing aid system that can reduce background noise, enhance speech clarity, and validate improvements using spectral analysis. I used Altair Compose to process an input voice audio file. The audio signal was passed through various DSP techniques like digital filtering, adaptive gain control, and spectral noise reduction. Specifically, I applied bandpass filtering to target the critical speech frequency range between 500 Hz and 3400 Hz, while suppressing unwanted frequency using a high-pass filter. The output after processing was saved as a new .wav audio file, that is output simulated file. Once the audio processing was completed, I imported the output .wav file into Altair Embedded for real-time analysis. In Altair Embedded, I used PSD, power spectral density block, and a spectrum display to visualize the graphs energy distribution of the processed audio signal. This helped me confirm that the unwanted low frequency noise below 500 Hz was significantly reduced and the speech frequency bands were amplified based on the PSD analysis. I observed a 30 to 40% reduction to noise and a 10 to 20% reduction gain improvement in speech frequency compared to a raw input. These improvements were clearly visible in the real-time plots generated in Altair Embed. Throughout the project, so basically what this project does is, so a small children who can't hear the voice or who are dumb, they can recognize the people's voice through this project. So which is basically a major objective for my future enhancement. Throughout this project, I learned how digital filtering, spectral suppression, and adaptive gain techniques can be combined to enhance audio signals for hearing aid application. I also understood how valuable real-time spectral analysis is in validating the effectiveness of such DSP system. So let's see the. So this is a program I used for DSP analysis. So this is the original output, and this is the filtered one. So when I plot this graph and after running this, we get a file named output simulated. So this is where we can use it for, we can use it in blocks. So at the microphone I inserted the .wav files. Now when I run this, we get this files. This is a performance time using PSD and spectral display. So you can see the waves which are the where you can see the performance gain in the improvement of speech frequencies. So in the future, I plan to move the system from offline .wav file processing to real-time microphone input. My goal is to implement the same system on low-power DSP hardware or microcontroller for hearing aid devices. I also plan to explore integrating AI algorithm for adaptive filtering and personalized hearing profiles, like hardware like STM32, etc. So this project has given me practical experience in building a DSP-based audio enhancement system and analyzing its performance using Altair tools. Thank you for listening to my presentation.